Newton's law of motion describes the way in which force and mass and acceleration all interact with each other. If we did an experiment where we could attach weights to a cart, we could load some of the weights into the cart and tie a string over a pulley and hang another weight off of the end of the pulley. This hanging pulley would apply force to the cart, which would cause it to move this direction. It would actually accelerate. If we measure the amount of force and the amount of mass and the amount of acceleration, we get a couple of very interesting relationships. First, if I graph acceleration on the vertical axis and force on the horizontal, force would be independent. I'd be changing the force down here on the string, and measure the acceleration that results, we get a nice linear graph. Acceleration is proportional to force. On the other hand, if we leave this hanging weight alone, never change it, and take mass out of the cart or add mass to the cart, what we get instead is that as the mass gets bigger, the acceleration gets smaller. It's tougher for this force to pull this mass and cause it to accelerate any more than it already has. Likewise, if we reduce the mass, the acceleration gets bigger. It actually turns out to be an inverse relationship, and acceleration is proportional to 1 over the mass. Combining those two things, we get a nice equation that says acceleration is equal to force divided by mass. Remember that acceleration is the change of speed with respect to time. And so combining these two equations together, we get that force times time equals mass times the change of velocity. I call this Newton's law of motion. Actually, there's two, typically they're called Newton's first law and Newton's second law. They really both come out of this one equation. Basically what it's telling us is that if the velocity is going to change, there are several factors that play into that. Number one, the amount of mass you're trying to accelerate. Greater masses, you'll get less velocity change. Smaller masses, easier or greater velocity changes. If you apply a force, greater forces, more velocity change. Smaller forces, less velocity change. And time, if you apply the force for a greater amount of time, you get greater velocity change. If you apply the force for less time, you get less velocity change. All fairly straightforward and common to everyday experience. But these four things in this equation all kind of play together. Part of what we're going to be learning over the course of the next unit will be how we actually apply that information to things like balanced forces, trigonometry, constant velocity or acceleration, right? How all those things kind of play together and how this equation kind of ties all those bits together all at once.